Dear all esteemed speakers, good
Good
morning
morning.
and good morning, and a very warm welcome to the third day of the Sustainable Place Conference and to this great workshop called Integrated Storage Systems for Residential Buildings. Please make sure you have you are in mute so we don't have noise in the background, please. My name is Ines Arias and I'm a European project manager at FEUGA, the Galician Enterprise University Foundation, and I'm today's moderator. I have the privilege of navigating us through this session organized and hosted by 4 European projects: Minister, Heating Site, High Build, and Integrity. During the next 9 minutes, we will put the spotlight on a new wave of innovative energy storage systems that will not only improve energy efficiency, but it will also improve the integration of renewable energy resources and will help enhancing European energy security while tackling energy poverty and unemployment. This is a cross-cutting issue and a key action for the transition towards EU's carbon neutral economy. It is safe to say to our virtual audience that this session isn't a theoretical blah blah. Today's intervention is about concrete examples and systems that have an enormous potential. We have 5 splendid guests on our panel this morning and one great opening speaker, and Regis from R2M that is making sure that everything will run smoothly on the background. But we won't be doing all the talking this morning because we want to hear your voices. We can't see you, but we can read your questions and comments on the chat bar. We will review and filter this, and we will pose as many questions as possible to our speakers. There are strict rules, though. Please make sure you write concise questions or comments. Say to whom these questions are addressed, and if you like, who you are. Any questions we don't have the time to take, please remember that we will endeavor to address them all afterwards. And speaking of interactivity, you can tweet your words of wisdom to your peers in the wider community using the hashtag integrated residential storage and by tagging this conference at sustain places. So enough about me for now. So who is our opening speaker? I take great pleasure in asking to join us today Dominique Blanchon. Dominique has an extensive and fruitful experience as a senior program officer at the European Commission DG for Research and Innovation, focusing her work on energy efficient buildings. So with no further ado, please, Dominique, the floor is yours.
Thank you very much, Ines. My job now, I will give a very warm welcome to everybody, but my job now is focusing on Northern Europe, so on the Green Deal that I think everyone has heard about it, and more than ever, we are all responsible to make it happen. So we are very busy now with the preparation of the work program 21-22 for Horizon Europe. As you might know, energy efficient building program is terminated, but will be continued by another partnership which is called Build for People, which is currently led by NR. And this will be accompanied by a political action plan, which is called Renovation Wave, which is really important also to implement this decarbonization in buildings and in the renovation of old buildings. And for the Prosperity Directorate now in RTD, it's not that we will be involved anymore in energy efficiency of building, but we will still have a section in cluster 4, destination 1, which is called a new way to build, which is really dedicated to construction and mainly to digitalization and industrialization of construction. So it will be focused on the construction site, making more efficient, more digital, and will apply all the robotics and the new application that you could dream of to have efficient constructions with high quality control and very much less waste. Another aspect where I will be involved, because I will not be involved anymore in construction, but in circularity. So I will deal with apps for circularity, which will be very important also for the Green Deal and the decarbonization, and also for the construction sector, because we will have in 2022 a very, very big project which will involve big demonstrator on solid waste. Solid waste are really important for the decarbonization because they can save a lot of feedstocks and a lot of manufacturing and construction also work, and as such save a lot of carbon. So that will be my next task, and I hope you could be involved also in circularity and storage. Storage will be very important, and green energy and renewables, and also heat storage. So a lot of integration of energy will be needed for this app of circularity, and so this is a main topic. So I will give you the floor, and thank you for all your presentations.
Thank you very much, Dominique. Thank you. You are not in the panel of this session, unfortunately, but we would like to thank you to have taken the time today from your very busy schedule to be with us. So thank you. So, so today we have an excellent set of speakers in our panel that will introduce to all of us for European project. We will have, by speaking order, Carlos Ochoa with the project minister, Francesco Pizzocolo from Heat Inside, Gabriel Semsbinsky from High Build, and Lorenzo Corti and Giuseppe Mastandrea from Integrity. I already apologize for my pronunciation. But why focusing on integrated thermal storage for residential buildings is so important? So the EU energy transition to achieve 2030 climate targets and a very ambitious and needed 2050 roadmap for a decarbonized Europe puts in the spotlight serious realities, such as the fact that an estimated 97% of the European Union building stock is considered inefficient, and around an 80% of this building stock will continue to be utilized by 2050. So measures needs to be taken, as Dominique said. The majority of the existing European residential buildings stock was constructed before the Energy Performance of Buildings Directive, the EPBD, which mandates requirements for energy efficiency of buildings, including the reduction of thermal energy demands in buildings. And as such, there is a large potential to achieve this by using solutions that can be integrated to existing dwellings and through different measures. And one of these measures, it brings us here today to optimize the use and management of thermal energy by allowing it to be stored to level demand peaks and increase the use of renewable energy sources. Thermal energy storage systems offer an increase in the overall efficiency and better reliability when applied in an energy framework, leading to, of course, better economics, reduction of investment and running costs, as well as the reduction of carbon dioxide. So as said, today we will have the pleasure to see the solutions featured by 4 European projects: Minister, Heating Site, High Build, and Integrated. Our first speaker of the day is Dr. Carlos Ochoa, Senior Researcher at the International Energy Research Centre, based at Tyndall National Institute in Cork, in Ireland. And Carlos is Project Coordinator of the Horizon 2020 Project Minister. He's an architect with a specialization on sustainable environmental design analysis. He has a PhD and an MSc from Technion Israel Institute of Technology, where he researched on the efficient use of energy and daylight for human comfort and architectural planning of intelligent facade elements. He is also knowledgeable on sustainable designs of climate adaptable buildings using both passive and active technology. He was a senior researcher at the EU project RECO 2SD, BRISIRE, and MIFS, where he helped develop climate strategy for prefabricated facade systems for energy savings and planning of computer selection programs. Please welcome warmly from the comfort of your homes or your offices, Carlos Ochoa. Welcome, Carlos. The floor is yours.
Thank you, Inez, and good morning, everybody. I will show and introduce the Minister project. My name, as you know, is Carlos Ochoa. I'm working at the International Energy Research Centre in Ireland, which is part of the International Institute. And the main points of the Minister project: this was awarded as part of the Horizon 2020 call EEV05 of last year, and it started in November 2019. The main aim is to develop a compact residential thermal storage system that is based on thermochemical materials, which is calcium chloride together with ammonia. And this project is being developed by an international consortium of partners from several EU countries, Switzerland and the UK. These are the partners. The consortium is led by us, the IERC, and it has a participation of different types of members, such as academia, industry, research institutes, certification bodies, non-profit organization, as well as local government. So it's a well-balanced consortium. What are the main aims and what are we working for? We are trying to reach 10.6 times the storage capacity of water, and we are using photovoltaic thermal panels to power the process. Since the call was asking for less than 1 cubic meter of storage material, we have calculated that with a total of 0.72 cubic meters of storage material, we can have a flexibility for storage using a parallelly TCMs, thermochemical materials, and PCMs, phase change materials. The payback period will be estimated at 6.7 years by achieving an energy reduction of 44%. And we also are trying to make it a multifunctional system that it will combine thermal and electrical storage by using a home energy management system. So this will bring even more added value to the user. And this is the concept. As you can see, the system is powered by PVT panels that you can see on the right, and you can have both heat and electricity. The electricity is stored in a battery, which you can see at the bottom, and it can also sell the excess electricity to the grid according to different grid signals, and this is managed by a home energy management system, which you can see at the top of the box. This home energy management system is also controlling both the thermal and electrical storage. The thermal storage itself has both heating components and cooling components so that it can provide heat and cold according to the season. But how does the thermal storage work? It uses solar-based renewable energy resources and combines thermochemical materials which store the heat in the form of chemical energy. And they are contained in a sealed vessel, which is called the thermochemical material reactor, and is used for daily and multi-day energy storage. The phase change materials are used in parallel, and they store the latent heat that is generated from the thermochemical. And they are used to supplement the heating and the cooling in the system. The energy storage density is over 180 kilowatt hours per cubic meter. This is more than 10 times the energy storage density of the water, and this was one of the key aspects of the core that had to be achieved. The innovative photovoltaic panels and thermal collectors provide the heat input, so this means that we have a sustainable source of heat. And the photovoltaic panels also produce the electricity that is stored on the electrical battery system. And the main components of the system are the thermochemical reactor, as I was mentioning. The typical capacity is 30 kilowatts per hour, and a two-step reversible reaction is used for the thermochemical storage. You can see here the formula. Then the ammonia cycle includes all the mechanical devices that are used in a typical refrigeration cycle, such as a compressor, a condenser, heat exchangers, etc. We also have a heat pump that upgrades the heat that is released by the ammonia condensation. We have the phase change material vessels that will also make the parallel heat storage according to the location, either with heating and cooling or just heating. And the solar field and battery storage, they produce the input and electricity that is required. How does the system work? In the charging phase, which can take place during winter and autumn or spring days, the photovoltaic panels receive the energy from the sun, so either the electricity is stored or the heat is transferred to the thermochemical reactor, from which we have an endothermic reaction. The endothermic reaction makes the gaseous ammonia to be stored in an ammonia condenser, which we can separate in an ammonia tank that is condensed, and the condensation heat is then separated and upgraded through the heat pump, which is then taken to the phase change material vessel or directly to the house in order to provide and cover the heating demands. This is for the charging phase. The discharging phase, in winter when there is no sunshine, the ammonia tank, it really evaporates the liquid ammonia and is led to the thermochemical reactor, and the evaporator makes it back again into its gaseous form. The thermochemical reactor produces an exothermic reaction, and then the heat that is released can be both placed again into the heating system of the household or into a phase change material vessel in case it's not needed. So we can still have some flexibility in using it. It has been calculated that the coefficient of performance of the system during both the charging and discharging phase will be about 1.8. So this makes it more efficient than having just a simple water-based storage. The discharging phase, which can be used for the warm summer nights, is that the ammonia tank is evaporated, and then we have gaseous ammonia that is then turned back again into the thermochemical reactor. Then the evaporated ammonia can release cooled capacity, which is then used for the cooling system in the home or into a phase change material with cold storage. So we have an efficient system that can provide both heating and cooling, so it's useful for both seasons. And where are we going to demonstrate this project? It will be demonstrated in a variety of sites that are located in Greece, where we have 2 locations. In Hungary, we have 1 location. In Ireland, there is 1 location. And in Spain, there will be a new demonstration site, and we are in the process of making official its participation. These are the demonstration sites in Europe. As you can see, we are trying to cover the 3 main climatic zones of Europe. We have the warm Mediterranean area, and this is covered by the demo sites in Thessaloniki, Greece, and this is the site of the smart home by the CERT ITI Institute. We have in Chimeria, Greece, the site by the Democritus University of Stras in some student dorms. We have in Sopron, Hungary, a private home, as well as in Cork, Ireland, which is a private home. And Cork is covering the temperate climate, while Sopron is covering the colder region. And now I want to bring my 2 cents into the discussion that we are going to have afterwards, which is saying, okay, we have a wonderful system, but why we don't have these systems in our houses? And according to what I think, these are the 4 main factors: the technology, price, the existing regulations, and consumer acceptance. And why this? Because for technology, we still need to exploit the potential of different materials that are out there, but in a way that is safe and can be implemented in a commercial scale. And even if we have the technology, this technology has to be accessible, because we are competing with well-established technologies. Even our water boilers can be optimized, and they can be a competition against thermochemical or phase change materials. Regulation must also address the latest developments, because, for example, the very first refrigerators at home were powered with ammonia, but due to the lack of existing technical developments of those times, they were abandoned for the fluorocarbon gases. But now that we have again regulations that we have technology that can address more safely the transport of ammonia, then the regulation can also take this into account. Also, consumer acceptance must be addressed, because if the consumer is not convinced of the system, either by price or by the safety of the technology, it will never be accepted. And this has to show the mitigation of risks, that, let's say, we have even dangerous materials in our homes, but all the risks have been mitigated through proper technological developments. So with this, I would like to thank everybody. This is the project website, minister.eu. We also have a page on LinkedIn, and we also have a Twitter page. So thank you very much for your attention.
Thank you very much, Carlos. I believe, Reggie, that we have some questions for Carlos in the chat, or?
Indeed, yeah. Thank you very much, Carlos, from my side as well. So we do have a question for you from Brian Cassidy, and he's asking you, what is a phase change material? What does the term phase mean in this instance?
Yeah, phase change materials are materials that can change from solid to liquid, or even to gaseous, according to their own properties and the type of heat that is applied to them. In this case, we are using some waxes that can store the heat, and then when they are heated, they can turn into liquid and then release this heat.
Thank you very much, Carlos,
Yes.
for the clarification. And I think in the presentation from iBuild, we'll talk also about phase change material as well. We have another question, and the question is: during cool winter nights, what provides the heat for evaporation?
Well, the heat has been, there can be also a backup heater, which makes a small quantity of heat and then start the reaction. And then this heat builds up, and then we can have more heat release.
Perfect, thanks, Carlos. I see we have another presentation asking whether we'll have presentations from this session, and indeed, and just like any other session at Sustainable Places, we'll make the whole recording of the workshop available on the website, and also each individual presentation will be available for download. So don't worry, this will come after the end of the conference.
Yeah. Okay, thank you very much, Carlos. If you have any other questions, just please write them in the chat and we will bring them to the debate time. So our next speaker, yes?
Yeah, sorry, there is just one last question if we have time.
Okay, there we go.
Sorry for that. So the question is, what is the melting temperature of PCM that has been used?
Well, that one, I don't have it at the tip of my tongue, as they say, but I can find it out.
All right, so Mohamed will follow up offline with your question.
Yes.
We record also all questions. Everything is monitored, and so we have your emails, so we are able to follow up as well after the presentation. Thanks. I'm sorry.
Yes, thank you.
That it's okay. So if there are more questions for Carlos, we will bring them to the debate. So our next speaker is Francesco Pizzoccolo, Project and Transition Manager at TNO, the Netherlands Organization for Applied Scientific Research. Francesco got his master's at the University of Brescia in Italy in 2008 as a civil engineer. And during his career, he developed a broad knowledge about materials behaviors in different fields: energy, pharmaceutical, biomedical, and automotive. So after working as a researcher for 4 years at the Eindhoven University of Technology, in 2013, he moved at TNO as a scientist in the Applied Geoscience Group. And since 2017, he is a project manager in the Material Solutions Department. Francesco is responsible for many projects in the energy sector with focus on materials performance. And in his free time, he is a basketball head coach at national level. That's very impressive as well. So please, Francesco, the floor is yours.
Thank you, Ines, for the introduction. I'm the project manager of the Eat Inside project, so I'm not really involved in the technical development, but more in the manager, marketing, and business side. So Eat Inside is a shortcut for bringing advanced heat batteries in residential heat and electric system close to market through real-life demonstration in different climates. So it was a very nice to see presentation of Carlos, because we are trying to develop similar concept using thermochemical materials. So the whole project start because the EU aims to increase the energy share up to 32% in only 10 years time. But of course, this transition comes with big fluctuation in supply and demand. So it's really important to have a system that can store energy and be delivered when needed. As most of the audience will know that the main use of energy in the household is for heating. So in Europe, it goes up to 64%. But at this moment, on the market, there is no compact and affordable solution to efficiently store and supply heat based on the user demand. So the main objective of our project is to advance this groundbreaking closed-loop heat storage concept to technology readiness level of 7. And then to go through a real-life validation in 3 different European climate zones. And so at the end, we really like to deliver an affordable, so in the range of €8,000 and a compact solution with robust, so will last up to more than 25 years performance. So combining hybrid functionality with compact storage with high efficient heat pump, and then to have a configuration for both heat and electricity system to create new opportunity for grid flexibility. So in our project, we did not start from zero because we already have a validated full-scale demonstrator, as you see in this picture. So this is a technology that it was developed as a combination of TNO and Eindhoven Technology University. And my colleague Pien Donkers, that is the technical lead for the Heat Insight project, has been working from this system for quite a while, because he started for his master thesis when he did his PhD on to develop this system, and he now is 3-4 years as well at TNO. So there are two main breakthroughs in our technology. So we are using a very stable thermochemical material, and is a very robust closed loop reactor system. So this thermochemical material and is loss-free. So this means that is very stable when the water is hydrated. So when it's a salt, and when the water is stuck in the crystal, it maintains a very good energy density and no energy lost. So it's stable, has a good power, robust, can last for a long year and many years. Is very environmental friendly, and to be chargeable is enough to have a pretty low temperature. So is a very simple system. So it has only 4K components. So on the top right is the reactor, is where the thermochemical material is stored. And during the project, now we are finalizing the design on a optimized system that is smaller and more efficient. Then below the reactor, there is the heat exchanger, then the ventilator, and on the top left, there is the evaporator and condenser. So how does our system work? So we have a discharge and a charge phase. So in the discharge, so we have the cold air that go through the condenser became to be wet, and then it enters into the reactor, and the reactor gives as an output a warm, dry air. During the charge phase is the other way around. So the battery to be charged needs to have an inlet of warm, dry air, and then go through and became a cold, wet air, and then dry air, and so on. So this system is quite robust, is already be tested for several cycles, and is very stable. So what we are combining is 3 main technologies. So we have a multi-cyclic stable thermochemical material, the salt. Then we have combining with a compact thermochemical heat storage system, and then we interface with the energy management of houses or house complex. So we have household, that you see the picture in the middle, that there is the thermochemical material connect to the water boiler for your daily storage, but this can go for shower, heating system, washing machine, etc. So the reactor contain approximately 1 cubic meter of thermochemical material. Your daily storage, it gives you like a water buffer for approximately 2 weeks of the hot water that is needed. And then the local production comes from the solar collector. Then we are working on different use cases. So the house can be connected to a low temperature heat network. So for example, when a centralized production of geothermal heat. So there is an inlet in your house of low temperature that you can use to charge the battery. or there is a use case in which the heat pump is connecting to your thermochemical storage systems and the electricity as a centralized production that can come from a solar panel or wind turbines, for example. So we have 3 pilot demonstrations in different climates. So the project started 1 year ago. We had this week our third general assembly, and the new reactor system will go in production around May, June in 2021, and will be some extra tests and optimization that have to be done before, and then we're gonna build several machines that are going to be installed in the spring of 2022 in 3 different locations. So will be 2 houses in Eindhoven, the Netherlands, with temperature ranging from 4 to 22 degrees and hours of sunlight 2 to 7 hours a day. I'm going to be in a very nice location in the south of France, in Saint-Paul-les-Durance, with temperature ranging from 7 to 25 Celsius and 5 to 12 hours of sunlight. And the last one is in Poland, in the north of Poland, Gdansk, with temperature ranging between -3 and 18 hours of sunlight, 1 to 8. In the last year and a half of the project is really going to be focused in installing first the machine to the demo sites, and then collect as many data as we can about performance of the reactor, the material, and the energy consumption of the houses. So we will integrate our system with a heat pump solar collector. So the air side of heat pump is combined with solar panels, and then we're going to be a smart integration of the condenser side in the heating system to have, and also to have a direct electrical charging. So what is in development now, we have a selection of concept, and that we have to adapt to the demo location. Then we will have to integrate our battery with the existing system, because of course some renovation of the house will be necessary, but we want to have our system as many flexible possible to be easily adaptable to all kind of different houses. Then we will be tested under real end user condition, and then we are developing all the ROE, safety, business case, and life cycle assessment. So this is our work plan. I don't want to spend much time in this. Just want to show you that every part of the system is strongly connected. So the material development, for example, needs to go hand by hand with the reactor development. So we have a strong collaboration between all partners, and so far as a project manager to say that I am extremely happy how the project is developing. So this takes me to who's in the project. So what I found very cool that is we mobilize all the key players for the present and future manufacturing distribution change of the heat battery. So the TUI, the University of Eindhoven, together with Evonik and Caldic, we are working on the industrial material production, material manipulation, and optimization. This, for example, involve which is the best dimension of the thermochemical material piece, which is the size, which is the shape, how the airflow inside the system, etc. Then as TNO, we are also involved in the material manipulation, but also in the optimization of the system design, because we want to make it a bit smaller what it is now, so it can more easily fit in private houses. And then we're also working together with BSOL, Ventilair, SEC, ENGIE for the network integration. One of our main partners is a CA, that as well they are working with us for the design system, but also they have a very strong role in the network integration and the demonstrator user validation. Eindhoven is simply the city. All of Eindhoven is involved for the demo site. Sint-Truidenbroek is a social housing in Eindhoven, and Fasada is the Polish partner that is providing help and a demo site there. Last part of this funnel is a settlement, is a Swiss company that is helping us with the exploitation of the product on the market. And they are already conducting several interviews with end users and the main stakeholder of this kind of system to understand, as Carlo mentioned before, what are the end user needs. Otherwise, it will be difficult to have a success on the market. But not only, so we are working with, for example, with architect and industry, because we really like to know how can we put this kind of system into the house market and in the new house market as well. So in total is 12 partners. We come from 5 different countries. Budget of the system is a bit less than 8 million euro. And project started October last year, and it will run until March 2023, so a little bit more than 4 years. So with this is our website. Please give a look at it. We have also some very nice videos on the website and on YouTube that explain how the system works and what are the potential. One last thing that I like to remark is that the system is there and is working. So we are just want to make it as most efficient as we can, but is there. And we are as well in the process of working with the Volt partner to really create a company to bring this system to the market. If I have a minute, so of course, yes, still 3 years to go to really bring the system to a very high technology readiness level. So what we are, the challenges for now is to optimize the thermochemical performance and to minimize the production cost and the size of the reactor. And then we are working with several partners in the manufacturing industry to understand how we can upscale the production for both the thermochemical material and the machine. I hope I did not talk too fast, and if you have any question, I'll be happy to reply. For the technical question, I'll do my best, but it's not my expertise.
Thank you very much, Francesca. We already have a question from Mohamed Fadel. I'm sorry if I'm not pronouncing that correctly. If you have more questions, please take a moment to write them on the chat. The first question could be, what is the reactor operating pressure and the TMC hydration, dehydration, and temperature range?
To charge the battery, we need about 40-50 degrees, and then the range of the heat that in the discharge phase is around in the 70 degrees. And then Ines, what was the first part of the question? Sorry.
The TMC hydration, dehydration, and temperature range, and the first one was the reactor operating pressure.
The operating pressure, we're working to have a flexible pressure system. So at this moment is working the machine that we have at atmospheric pressure, but the final machine will be a bit higher pressure. And the exact number is just not clear yet. We just want to have a system that work a bit higher pressure, but we are not there yet.
Okay. I think there are no more questions at the moment. Is it correct, Regis? I think, yeah. Okay.
Correct.
Okay, that's perfect. Then, if you have more questions, we can leave them for the debate time. Then now we continue to our next speaker. He is Gabriel Semsvinsky, researcher and high-build technical coordinator at Universidad de Lleida. He holds a PhD degree in physics from the Autonomous University of Barcelona in Spain. Since 2010, he has been part-time lecturer and researcher at Greya Research Group at this University of Lleida on topics related to thermal energy storage based on the use of phase change materials, energy optimization in industrial processes, energy systems, and refrigeration systems. Gabriel has participated in different European projects, FP7 and Horizon 2020, and he has been involved in the coordination of the EU Horizon 2020 impact tests and as a technical coordinator of the High Build project that he is today here to present. So welcome, Gabriel. The floor is yours.
Okay, thank you very much, Ines. So I have the pleasure to be here and thank you for the introduction. I have the pleasure to present you in these 15 minutes High Build project. So this presentation was prepared in collaboration with different partners of the project. So I would like to mention Andrea Fracica and Valeria Palomba from the CNR ITAE Research Center in Italy, and Johann Emhofer and Tilman Bartz from the AIT, from the Austrian Institute of Technology, and Luisa Cabeza, which is the head of my research group, Greya, at the University of Lleida. So these are this is the outline of my short presentation. I will try to explain High Build in a nutshell, and to explain also the overall concept and how the High Build project is being implemented, and focusing also on the innovative part of the project, and also the critical aspects that we have encountered during this period. So High Build started in October 2017, and it will end in March 2022. Originally, it was for 4 years, but due to COVID situation, a 6-month extension of the project was granted. So the overall contribution from the European Union is about 6 million euros. And the consortium is quite big. It has 20 partners from 9 countries. And the project is coordinated by COMSA, which is a company from Spain. And as a technical coordinator, University of Lleida is contributing. So here you can see the logos of all project partners. And on the bottom part of the slide, you can see the link to the web page of the project. So what are the main objectives of the project? So basically, High Build aims to develop 2 innovative hybrid storage concepts. So the first one is mainly for Mediterranean climate region, and is meant primarily for cooling applications, to supply cooling to residential buildings. And the second one aimed for continental climate regions where heating is dominant, but also the system is planned to supply domestic hot water. Both concepts are based on innovative components, such as a compact sorption module in the case of the Mediterranean climate system. Then there is a high density latent storage based on phase change material. There is a reversible vapor compression heat pump, and also a DC bus interconnection between the electrical components. And the whole systems will be properly managed by an advanced control implemented in a building energy management system. And the system will be tested, will be validated in 3 different demo sites. So here you can see we have these 3 demo sites. The first one is located in Almatret, which is a small small municipality between Barcelona and Lleida, where the Mediterranean system will be tested. Then we have one demo in Langenwang in Austria, where the continental system will be tested and validated. And finally, the third demo site is located in Cyprus, in Aglantia, where again the Mediterranean system will be validated. So let me briefly explain you the concept of each of the systems. I will start with the Mediterranean system, which, as I said before, is mainly aimed for cooling applications. So we have a absorption module, which, as I said before, is only here in the Mediterranean system. The idea is that this absorption module is fed with hot water coming from renewable solar collector fields using Fresnel collectors. And on the other side, another thermal storage system is a low temperature latent storage based on phase change material. This phase change material is placed in a compact heat exchanger, which at the same time is the evaporator of heat pump. So the heat pump is connected on the low temperature side with the latent storage, and on the high temperature side at the condenser, it is connected with the absorption module. This is the idea is to enhance the efficiency of the heat pump by doing these connections. And I have to say that the heat pump is fed from a DC bus. So it works with DC current. And well, finally, the system also has an electric storage, a battery, because the overall system, the electric part or the electric demand of the system is met by a field of PV panels. So the surplus of PV of electricity generated by the PV can be stored in the battery, or if the battery is full, it can be sent to the electric grid also. Regarding the continental system, which mainly is aimed to provide heating and domestic hot water, but it can also work in cooling mode. Here also there is latent storage, but in this case, the latent storage based on phase change material is located at the outlet, so at the discharge of the compressor of a heat pump, to store the high temperature refrigerant or the energy sensible part of the energy in the refrigerant coming out from the heat pump. Here again, the heat pump is fed by directly from a DC bus, and in this case the evaporator is located in the outside. In this system there is also an electric storage, which is as in the Mediterranean system, is fed by an installation of PV panels. And here again, the excess of electricity can be, the surplus of electricity can be sent to the grid or stored in the battery. Regarding the implementation of the project, so here we have a summary of the timeline. I have to say that this project is research and innovation action, so the level of the TRL level is quite low. So the idea is to take the technology from levels from 3, 4 up to 5. So during the first year, the project focused its activity in defining the key performance indicators and also on modeling and design of the components, the main components of the system. Then in the second year, these components were integrated and tested at lab scale, and also their design was optimized. In the third year, a control development strategy was implemented, was carried out, and also the monitoring, 1 year monitoring of the demo sites before the intervention, before installing the system, was also performed to see the energy behavior of the demo sites before installing the system. In the fourth year, is devoted to the installation and installation of the systems, integration of all the components at the demo site, and during this period, the monitoring of the system after its installation will also start. So during the last month of the project, so after 4 years and a half, we expect to have a full year of demo site monitoring of the system and also a system validation of the models that were used for the analysis of the replicability of the system. So here in this slide, you can see pictures of the continental system on the top of the slide, where you can see the main components. And at the bottom of the slide, you can see the Mediterranean system, where the latent storage integrated with the heat pump and also the sorption module and the DC bus with the battery can be seen. So let me briefly explain the innovation that is carried out in HyBuild. From the call that was EEB 06 in 2017, it was stated that hybrid approaches encompass different aspects which may be addressed separately or coherently. And it was mentioned that high efficiency conversion and storage of surplus renewable electricity into heat. It should also contain multifunctional use in both heating and cooling applications at different temperature grades. And it should also involve different timescales, for instance, seasonal storage of high temperature solar heat and peak shaving in low temperature heat pump applications. So the project tried to address all these points that were stated in the call. So regarding the first one, high efficiency conversion and storage of surplus renewable electricity into heat, both systems are based on reversible heat pumps, where the electricity coming from PV is converted into thermal energy, both for heating, cooling, or domestic hot water. And well, the innovation is at heat pump level, where the heat pump is fully integrated with both sorption and latent storage. Regarding the multifunctional use in both heating and cooling applications, so both systems can provide either cooling or heating, although the Mediterranean concept was specifically optimized for cooling, to provide cooling, okay, with an increased COP of the heat pump thanks to the sorption storage. And in the Mediterranean and the continental concept, the idea is to recover and store the energy from the superheated gas that comes out from the compressor of the heat pump. And this heat that is stored in the PCM can be used later for providing domestic hot water. So the overall COP of the system is increased thanks to the storage, to the latent storage. And regarding the different time scales, well, in this project, we have a sorption module that possibly can operate both on short term or long term. storage. Actually, in this project, only short-term is used. Then there are latent storages that are used to increase the flexibility in operation and also for the efficiency, improving the efficiency of the heat pumps on a daily basis, while the electrical storages are used to further increase the flexibility and also the self-consumption of the system. So before finishing the presentation, I would like just to mention a few critical aspects of the implementation of the system. The first one would be the integration of both of these three components in the Mediterranean system, which are the heat pump, with the absorption chiller, and with the latent storage. This can be a critical aspect of the project. Then the overall system logic definition and implementation is another critical point, because the systems are very complex and it's not that straightforward to implement control in this kind of systems. And finally, potential critical aspect is to have a continuous 1 full year of monitoring of the system after its installation. So given the low level of this technology, we expect the system to have to work, but being optimistic, it will work for a full 1 year. So hopefully this will be the case. If not, at least we will be happy that the system can work at least during a period less than 1 year. So to conclude my presentation, in HyBuild, we will develop innovative, fully integrated components for both electric and thermal storage solutions at domestic level. The developed solutions will be optimized for both heating and cooling applications, and we will use 3 demo sites to validate the solutions. The lab scale system has been completed and tested. Well, their testing are completed under lab controlled conditions. And well, a critical aspect of the project is represented by the overall system control of the system, or implementation of the control system at the demo sites. So thank you very much for your attention. If you have any questions.
Thank you very much, Gabriel. I think we have one question from Jose Tabogada Gonzalez, and he asks, what information you registered before the installation of the system, energy demands, or also weather and local demand measures, heat and cold?
Yeah, thank you very much for your question. Yeah, in the pre-intervention period at the demo site, we registered different data. For instance, temperatures and relative humidity, both inside the house and also outside, so the ambient temperature and humidity, relative humidity conditions. Also, of course, in the outside, not in all the demo sites, but in some of them, we also register solar radiation, wind speed, etc., etc. And also we also registered the current energy consumption of the buildings for heating, for cooling, if the cooling system is installed, and also the energy consumption for providing domestic hot water. Yeah.
Okay. Yeah, that's good. Thank you, Gabriel. I think there are no more questions, right, Regis? Okay, so we continue to our final presentation of the day before having a debate with our panelists. So our final 2 speakers for this presentation for the project Integrity are Giuseppe Mastandrea, R&D Manager at Energy at Work, and Lorenzo Corti from UNE, also R&D Manager. So Giuseppe Mastandrea, he holds an MSc in computer engineering and has expertise on real-time control systems, design and development for industrial environments, knowledge-based analysis and reasoning. He gained a significant experience in European research projects, working in FP7 projects such as NOL-EM and DARIT, and several Horizon 2020 projects. Currently, he is coordinating energy at work technical activities in the Recognition, eDream, and Integrity Horizon 2020 projects. And Lorenzo Corti, that works at UNE, is graduated in electronics engineering, currently holds the role of R&D manager, and has followed from the beginning the development of the project of the zero storage system, as well as other projects, including Integrity for UNE. He is currently also following several feasibility studies on industrial storage, and previously he has worked in the field of electrical, photovoltaic, and industrial automation. So welcome, Lorenzo and Giuseppe. Please, the floor is yours.
Thank you, Ines. Good morning. I'm Giuseppe Mastandrea, and I will present with my colleague Lorenzo the activities carried out on one of the pilots of Integrity project, in particular the pilot of San Severino Marche. I will briefly present the context of the project, our pilot, and the role of each partner of our pilot in the activities related to our pilot, while Lorenzo, as a representative of UNE, the company that have produced the energy storage system used in our pilot, will present the technology used for the energy storage system that we have installed in different residential premises. The identity card of our project. Our project is related different activities about the distribution of energy and the management of energies. In particular, in our project, we have developed different solutions for the optimization of the energy distribution and for the utilization of different storage technologies. The call which we have participated is LCE of 2016. The duration of the project is 48 months. The end of the project is expected by the end of the year, but probably will be granted 6 additional months of extension due to the spread of COVID-19 in Europe. The overall budget of our project is around 15.5 million euros, funded by European Commission for around 12 million euros. The coordinator of our project is out of Spain. Our project is an innovation action with several participants from Italy, Greece, Romania, Spain, UK, France, Cyprus, and Portugal, 30 participants. And we have 10 different pilots. San Severino is one of these. And the objective of our pilot is performing and optimizing the configuration of the medium voltage distribution network and exploiting the distributed energy storage system for the provision of ancillary service to the electricity market. The partners involved are ASEM, that is the local DSO in San Severino market, the Polytechnic University of Milan, Energy at Work, and UNE as energy storage system manufacturer. In particular, as regards ASEM, as I said previously, ASEM is the local DSO in San Severino market that have around 8,000 of users. The capacity of distribution network is around 50 megawatt, and the power produced by renewable energy system, photovoltaic, hydroelectric, or wind power, are 28.8 megawatt. In this slide, I reported all the installation that we have implemented in the medium voltage substation in order to retrieve the data useful for the analysis of the grid. In particular, we have used the SCADA system to gather the data and for the remote control of the switches in the grid. Polimi, in our pilot, have implemented a specific software for the optimization of different aspects. The aspect not related directly the energy software, the energy storage system are reported in this slide. In particular, the optimization of the production of forecast of the forecast of the production by renewable energy system, the optimization of the grid topology in the San Severino market, and the simulation of balancing market based on the technical and economical model of the Italian market for the energy. While the aspect directly related to the energy storage system is related to the dispersed energy storage system that we have installed on at different residential premises in San Severino, and a set of routines has been developed to gather field data, forecast, may implement the forecast of this data to return the scheduling of domestic batteries to provide the maximization of self-consumption, the frequency regulation, and local services for the SO, in particular for the implementation of ancillary service. Energy at Work in this pilot have developed and deployed on the central workstation of the DSO specific software able to get and set data to the energy storage systems using web service RESTful to collect stored data in the database used from Polytechnic University of Milan to implement the algorithms, to train the algorithm, and to send to the energy storage system the set point. We have also developed and deployed specific web service to externally expose the data for the integration with the whole integrity platform. I give the floor to Lorenzo, that as a representative of UNE, the company that produced our energy storage system, will present the technology used in our pilot.
Okay, thank you very much, Giuseppe. Can I have the possibility to share my screen? Okay, thank you very much. Just a moment. Okay. Do you see my screen?
Yes, we can see your screen, Lorenzo.
Oh, okay. So, good morning to everyone. It's a pleasure for me to have this opportunity to present the technology of UNE. UNE is an energy storage system producer, and we are working with nickel sodium battery technology, SALT, and our system is an all-in-one solution. Any characteristics are shown in this slide. For example, is total green thanks SALT technology, is safety. So because is there are no toxic gas emission, no fire, and no explosion. Is an all-in-one solution means that it has all components needs to manage and store energy. For example, inverter, MPPT, DC-DC, battery, and so on. And it has inside various functions like on-grid, off-grid, and backup. Just a moment. The next slide. Okay. Here is shown the position of the various components inside the system. You can see that there are MPPT, that is a DC-DC converter from PV panels to DC side to charge the battery through the photovoltaic plants. An inverter of 6 kilowatt of power monophase. A CPU board that is an electronic board where it's possible to manage the entire system. And the main function of this board is to manage all the components that are inside the system and to transmit the data remotely to our web server. And the battery, that is the positions of the battery is in the bottom of the system. In this slide, we have the main technical data. It's possible to connect up to 18 strings for the photovoltaic side. It's possible to have until 3 MPPT. The inverter is a 6 kilowatt monophase, 220 volts. The battery is possible for the storage is possible to have up to 2 battery of 10 kilowatt per hour for each one. There are 2 models, the cylindric and the square model. And is about the size is very compact because the system is possible to install the system in about 1 meter square, and it's possible to discharge the battery until 90%. The temperature range is from -10 to +40 degrees, and the battery life expected is about of 20 years. The system is certificated for Italian rules. Say C021, and so in this slide you can show that you can see that it's very simple to connect to connect and install the system because is enough to connect PV strings, DSO line, user AC, and an internet connection via Ethernet or Wi-Fi, and the system is ready to work. Next slide. Okay, it's possible also to manage it by remotely via web app or by your smartphone or via web. Where you can see the state of the system in terms of PV production, state of charging of the battery, DSO, and user power, and so on. At the installer or admin level, you can see and you can download log or upgrade firmware. Okay, What about the UNES role in integrity? We have provided 6 systems, installed 2 on labs and 4 on residential buildings, and we have developed various functionalities. We have developed active and reactive power and frequency regulation functions, and this is in local side. And we have developed a web server for remote management, reading and store data, writing set points, upgrade firmware and download logs, and also a web app for user interface, etc. And we have also developed an API catalog for external management for communication with ASEM, Polyme, and Energy at Work. In details, excuse me. Okay. About the remote communication, we have developed the parts highlighted in yellow on the right, using an SQL database to store data, a web server with an API catalog to read the variables and write set points managed locally by the systems. And so this is, I've finished. And if there are some questions, doubts, etc., I'm happy to answer.
Thank you very much. I think at the moment there are no questions, if I'm not mistaken, right, Regie?
That's right, yeah.
I think they are not. So thank you very much for your presentations. We can now have some minutes to have a chat together and a chat as well with our audience. So I ask you all, if you have any questions, please do so by using the chat box. These questions will be filtered by Regie. So please state always to whom these questions are addressed and who you are, if you want to. But please, in the meantime, while you type your questions, hopefully I have some questions of my own, so we can begin from that. I will address a question to each one of you, but if the rest have something else to add, please feel free to jump in. So I will just go ahead and ask a question to Gabriel from High Build. I would like to ask you, what kind of artificial intelligence based control are you implementing in the system?
Yeah, thank you very much for your question. Yeah, actually, it's a good question. It's this is one of the challenges, the critical questions of or points of the project. Actually, we are using different control strategies. So mainly three control strategies, all of them using artificial intelligence techniques. So on the one hand, we use an optimization based on energy management of the system, so as to provide flexibility services to the grid operator. And in this case, an heuristic algorithm is used, okay, based on non-dominant sorting genetic algorithm of the second type. On the other hand, we also use optimization based on minimizing the cost of the energy operation of the system. But also we have another optimization where we try to maximize the share of renewable energy used by the system. So for these last two optimization performed at the University of Lleida, we use reinforcement learning techniques, so deep learning control, basically.
Oh, no. Okay. Well, thank you. I think we have some questions that Carlos wants to ask Francesco, if I'm not mistaken. So there is a question in the chat. Sorry? For Carlos, sorry. It's too many screens. So for Carlos from Francesco, he says, I like the concept that you have presented. From first impression, it seems to be a complicated system to manufacture and install in the houses. So are you considering those aspects in the development of the project?
Yes, thank you for the question. It's a very good one. Yes, we are considering the installation and the manufacturing. It's based first on manufacturing techniques from project partners that they are developing the proprietary technologies, while at the same time, we are trying to keep with the existing standards, which are quite restrictive in case of the use of ammonia. But at the same time, we are also having testing of the system before installation. That's why we have two certification partners, so they will be giving some sort of approval for the system that it can be used safely at homes. On the other hand, we are also developing the logistics for the installation. So it's indeed a complicated task, but we hope to achieve it in a feasible time. Thank you.
Thank you. We have the first question in this debate from the audience. It is addressed to Lorenzo Corti. It comes from Marco Rocchetti. So the question is, I would like to know how the UNE market approach for the zero system. So are there directly a seller, or they are working with partners, for example, ESCO or resellers?
Yes, I've lost the communication for a moment, so I have been. Okay, thank you.
Yeah, I repeat the question. So Lorenzo from Marco Rocchetti, I would like to know how is the UNE market approach for the zero system? Are they directly a seller, or they are working with partners, for example, ESCO or resellers?
No, we work alone, but we have some partners. For example, battery manufacturer for the research and development, and our research and development department works together with battery manufacturer. And so we have developed alone the system that manage this kind of technology, and the battery manufacturer have I don't remember the word, excuse me for my English. So the battery manufacturer give us the battery, and BMS is developed in parts from the UNE.
Okay, that's good. Actually, yeah, I also understood, if I'm not mistaken, that after the session, you and Giuseppe as well, you would like to share with the audience a questionnaire. I don't know if you would like to tell us a bit about it. What would you need?
Yes, we have prepared a questionnaire to share with the attendees. We aim to make some analysis on the feedback from the eventual possible stakeholders. for our activities related the engagement of stakeholders.
Okay, that is good. And I think we have not, I did not pose a question yet to Francesco. So Francesco, can you let us know when the heat battery system that you have presented today will be available on the market?
So thanks for your question, Ines. Well, the idea, the plan is to have it available really at the end of the 2024. So the project will run until beginning 2023. And then we really need to, we are looking as we speak to the right partner to really go to serial production of the machine.
Mm-hmm. Because is there, I mean, still I imagine there are challenges that you need to overcome before getting to this market uptake of the technology. Can you let us know a bit about these challenges that you need to overcome?
Yeah, certainly. So at this moment, the system is too big, and is also from a very practical point of view, is very difficult to take it and install it in the basement of houses. So we are changing the design into a sort of Lego blocks system. So it's easy from someone to carry around and to put it in houses. So we are really finalizing the technical drawing to go to manufacture the first machine before the end of the year. And then at this moment we have after many cycles, sometimes the salt creates some conglomerates. So we need to and then plug a little bit the airflow for the system. So we are testing different techniques to make sure that the salt grains of the thermochemical material stay separate. I mean, it's not something that is not impossible to solve. So it just takes time and a lot of testing and experiment to be done. But we plan to have the system ready in 1.5 years, so we can spend the last year of the project for the installation and collecting the data in the demo sites.
Yeah, I imagine also this challenge regarding the size of the system is also a challenge that minister faces. Perhaps, I don't know, Carlos, if you would like to elaborate on that, or in any other challenges also that you face in order to take the technology to the market.
Yes, indeed, Ines, thank you. Yeah, as Francesco was saying, we also share the same difficulty, but it's also posed by the technology, since if you need to have a certain amount of energy release, you need also a proportionally amount of material to generate that heat. So that's still like sort of pushing the boundaries of the technology in order to make it as compact as possible. Of course, it's much better than what it was before. But again, we face the same type of challenges, not only from the setup, but also that some certain of the norms we are already defined to place it outside because of the use of ammonia. And nevertheless, the system has its own safety devices and it can run continuously. This type of system makes it suitable for long-term use, but at the same time, we still, because of the TRL level of the project, we're still not envisioning the full marketing. However, there will be a step into it so that the partners can also take it beyond that. But we hope that with this project, we can demonstrate that the technology is viable, it's usable, it produces enough energy in a green way, and that it will generate more market interest, which I think will promote again the technology to make it even smaller.
In the case of high build, Gabriel, we are talking more about challenges regarding the integration of the components, or is there other challenges that you need to overcome, and how will you do so?
Well, yeah, in the case of high build, also the TRL level, no, the level of technology is low, let's say. So of course we face some problems already in this sense for the integration of all the components, and that all the components as a system work well. This is really a challenge. So of course we had different, let's say, small problems, small or smaller or bigger problems, but also with individual components. We detected some problems, and then we had to improve the design, to deliver a component that could really work in the system and in interaction with other components. So for us, this was also a big challenge. Of the integration of all the components.
I see. Yeah, pardon, sorry.
No, at system level. So as you were talking before, about the commercialization or to taking the technology to the market. Of course, this is also a huge challenge. Hopefully, yeah, we will succeed to show that the technology is working at the demo sites, and then based on this validity of the technology, hopefully we can also find a place in the market. But still,
yeah, coming to that, I would like to pose a question to all of you actually, because regarding this market uptake, right? Carlos made a question in his own presentation, asking why we don't have high energy thermal storage in our houses, right? So he underlined the several problematics coming: technology, price, regulation, consumer acceptance. What is your position in this? Do you think these are right approaches? I mean, this is the right tackle of the possible problematics of why this is not happening, or do you have a different vision? That is open, so please feel free to comment on it.
Well, I can start my experience with the e-storage batteries that, well, first when we interview end users, as soon as we mention battery, they expect that we're actually storing electricity. And so that is already first clash that we get with the end users. So to really explain how important and convenient, both for the environment and for the family finances, to really just have also a storage of it. And well, I think at this point, for example, like solar, similar technologies are just much more advanced in the market, and yeah, much more cheaper and socially accepted than already heat pump is already less common and still very expensive and a huge thing in your house, while solar panels are just something flat that is in your roof and a bit out of your sight. So it's also been a big heat storage or a big heat pump is not for every house, while a solar panel can be on big majority of houses.
Yeah, I see. Gabriele, would you like to add something to this?
Well, yeah, I would say social acceptance is very important for this kind of technologies. I think people don't want to have, big installations, or even if they're safe, maybe they can think they can be dangerous. So I think they don't want to have unknown technologies, strange things in their house or next to their house. So I think also this is very important. Actually, in HiBuild, we have a task that tries to analyze this. So we have a social life cycle analysis of the project, where we try to see also from the social aspect, from the social point of view, how the technology is seen or accepted by the possible stakeholders. Of course, apart from the life cycle assessment or life cycle cost assessment, which are also carried out in the project, but So I think also the impact that the technology may have on the environment can also be very important.
Yeah, definitely. I mean, awareness raising is fundamental, right? If you don't inform people about it, and if you come to the consumer and it is the first time that they hear about such a thing, the first impression is always skepticism, right? Okay.
And I think a huge input can come from the regulators as well. But for example, here in the Netherlands, we have many cities or part of city that are going on an experiment to be a gas-free neighborhood. And so that is also above, so you have some tax incentive, etc. to just, that's also a very good push. Because if the technology is a bit too expensive, but then you have some benefit coming from government, that for sure is a help.
There you go. Yeah.
Yes, and I would like to complement Francesco's comment with that. I think initiatives such as the ones that are proposed by the EU are beneficial because they help to advance the technology. Otherwise, it's just a cycle of optimizing existing technologies and not going beyond just because of market constraints. But I think with this type of projects, we can show that there is a way forward and a different system that can be implemented.
Yeah, that is great. I'm afraid we are running a bit out of time. So before we close this session, I would like to ask of you for a final idea. So no more than 30 seconds, a sentence, a word, a picture, something that best sum up the outcomes of your presentation, and something that you would like the attendees to take with them to their homes, that I imagine most of them are there. So we can start, for example, Carlos, would you like to make a short summary?
Yeah, like high thermal energy storage is the future, and we can expect to see it in the coming decade.
That is great. Francesco?
Yeah, I first Carlos, great, and on top of that, and it can really, it can be something that is small, compact, and it is really going to help family also for the financial point of view, plus on the environmental impact.
Great, thank you, Gabriel.
Well, yeah, as you said, so I agree. Energy storage, renewable energies is the future, but I think it's very important to also use, proper communication skills to reach to the society and to tell them really that we are not crazy researchers, but we really do something that aim to improve their lives. So.
Exactly. Yeah. Giuseppe and Lorenzo, would you like to say something?
Yes, our aim is to motivate and engage the citizen in the participation of the energy market, on the energy market, to the exploitation of energy storage system and the optimization of self-consumption.
Well, then thank you very much to all of you. I would like to take all the time. So thank you, and that's it. We have a short announcement that Regis wrote in the comments. So this afternoon, starting at 2 set time, do not miss the renewable heating and cooling solutions for buildings and industry workshop. You will find how to register and the links to attend in the chat box. So I just would like to extend a warm thank you to all the speakers who have done great, and especially thank you to Regis, who has been making sure everything was perfect on the background, and of course the organization of the Sustainable Places conferences. And obviously, thank you to all of you for registering, for turning up, for posting intelligent questions. And please do not forget, if you have been inspired by the contributions of these great researches. Please do post them on social media, always tagging sustained places. So that's it for me. So it was a pleasure to share the screen with you all. And please enjoy the rest of the event. Thank you.
Thank you, Ines, everybody.
Thank you.
Thank you very much.
Bye.
Thank you.
Bye-bye.
Thank you very much.
Thank you.
Bye.
Bye.
Bye.